anticipated wrongly in 5G with millimeter waves. You need, of course, the right extreme massive MIMO technologies here. There's another important point here on this slide that I want to make. This proof of concept was not realized by Bell Labs. This proof of concept was realized by our mobile network business group at Nokia. Point being that we have transitions from the exploration research first phase to a more systematic R&D research phase. And this platform was realized on a commercial platform, the Habrok platform. New spectrum. The other one is new technology. Everybody agrees that the new technology that justifies the next generation is the use of AI, the rapid progress of AI and its capabilities. And as Bell Labs, we have reported on our progress on using AI even at the physical layer, and that there are performance gains up to 30% using these new technologies. And we're collaborating now with NTT Docomo and SKT to evaluate the performance of these AI technologies at the physical layer. But a very important key point is how will we in future achieve interoperability? And it is important because on one hand, device vendors and system vendors on the radio side will have their own secret source AI architectures, AI algorithms that you don't want to disclose. So how in a minimal way can you ensure the interoperability? And it turns out you don't need to exchange the architecture. You can have your own neural network approach or another machine learning architecture, as long as you train your AI networks on a common data phase, as shown on the left-hand side. I won't go into the details that beyond the scope of this opening session, but we actually have verified and tried this with a partnership with Qualcomm. Here, this is a test that we've done in Bell Labs in Murray Hill. It was snowy then as well, very fitting here to the Livy context. So the new technology, and then the new capability. Joint communication and sensing as a new capability for 6G that we are evaluating. So it's a radar, but it's not that we are reinventing radar. It is that we reuse base stations, not only for connectivity, but also for sensing the location of people and objects and their speed. And we've actually demonstrated that for real. We hacked a 5G small cell millimeter wave system and enabled that sensing capability. And we're currently testing it in an experimental factory in Stuttgart in Arena 2036 and evaluating possible use cases with another partner, Bosch, in an industrial context. Then after the new capability, there's also the new architecture. And there we're looking at how can we make that network, that multi-cloud integrated network, programmable in an efficient way, how we create services using microservices and cloud-native design approaches on top of such an infrastructure, symbiotically with the applications. And very important there is the use of APIs, application programming interfaces, using natural language models increasingly, and then also AI for the automation and the orchestration across all that infrastructure and across these layers, and doing that also in a secure and safe way. So I've given you a few examples of the progress that we have made in partnerships with the partners in different sectors. And now with this vast, there's many more things, and with this vast plethora of concepts, it becomes important to reconcile and what are really the priority items that we need to focus on when we talk about day one and when we enter the standardization phase. And we've summarized that here with 6. For 6G, having 6 such focus areas is a good way to memorize it. First of all, there is, of course, the extreme massive MIMO in the new upper mid-band above 7 gigahertz. There is then also the architecture, keeping that architecture, especially the RAN core evolution, simple. Let's not have 7 options, let's have 1 option. Then making that network programmable as advertised, having focus on those APIs and that openness, and then also having a framework in place for AI. Will all the AI algorithms and concepts be deployed at day one? No, probably not, but you need a framework in place for the interoperability, for the operations, the MLOps, for the lifecycle management, because it's such a fast-moving field. You want that next generation to be ready for it. And then do all these designs with security and trust in mind, and also with energy efficiency in mind as advocated. So with that, I'll conclude my talk, and I think we'll have questions in the panel afterwards. Thank you.
Thank you, Peter. And the third presentation in this keynote session is from Huawei by Egon Schultz. Presentation is being set up. I would like to point out to you that in your conference packs there's the latest edition of 6G Waves magazine, and it was particularly edited and made for this event. So it collects some of the highlights of previous 6G Waves magazines over the years, as well as some new ideas and thoughts from our colleagues.
Matti, thank you very much for the invitation, and all Alex. And I'm proud to hear. And I remember 2019, we contributed to the white paper actively from Huawei, and now we have to look how I want to go. And you know, the world is round, colorful, and dynamic. And the dynamic pushed the technology to new innovation. And as you know, every 10 years, the wireless technology will go through a revolution. This means 1G, 2G, that was for voice, 3G, 4G, that was for data, and 5G, that was to connect everything. And now with 6G, we will have new services and new innovation. That is now too fast. Yes. So this 6G, we will have enhanced communication in order to support more services like Emma said, digital world, to support extreme communication and also massive connectivity. That will be enhanced to 5G. And to addition, we will have two new services that will be sensing and also AI, artificial intelligence. In this case, also sensing will help us to improve the artificial intelligence. So this means we will have enhanced communication and plus the beyond communication in 6G. So maybe the key capabilities which we have in 6G is at first the network sensing that will be, it's coming maybe by the radio wave, we will have a reflection and we can make imaging, we can make a network sensing which can help also artificial intelligence as a service for artificial intelligence. Then we will have extremely connectivity. We will have a fiber link capacity very high. Then also we can support Industry 4.0 and beyond in order to support the machine. Sustainability, we already discussed this in order to save money and energy, and also that will help us to change the climate changing. And then the trustworthiness is also very important. In the first presentation, Elisabeth gave a clear concept. Then we have to connect the unconnected people. There exists some investigation to make the non-terrestrial network integrated in the terrestrial network happen. There exists also some trials. And here's also very important how we want to handle the system here. Will we operate by airtime at the satellite, or how they want to do it? But I cannot I will not believe that they will build their own satellite system. And then we have the native AI for the networks. This means that we can improve the wireless communication for AI, or also the network can to build a distributed network for the AI. Then, for the time being, there is a recommendation from for the IMT 2030, and if you're looking to the small triangle here, we see that is a 5G with enhanced MBB, also with ultra reliability, low latency, and with the massive machine communication. With 6G, we increase it to the massive communication, also to the hyper reliability and low latency communication. And here with the immersive communication with high data rate, new is then the integrated sensing and communication, AI communication, and also ubiquitous connectivity. And if you're looking to the framework recommendation of IMT 2030, then we have new capabilities, which already here in, and then the enhancement of the existing 9 capabilities of IMT 2020. Oh, that's very fast. Okay. So then typical use case are immersive communication. So this means that you can go in a play and you can play with guys in the systems. Which capabilities do you need here? You need higher data rates. That means up to 1 terabit, high reliability, low latency, and large capacity. Another use case is a higher reliability, low latency communication, maybe in the factory for the collaboration of robotics in order to produce products, or also in the e-health with haptic remote tailor operation. You need here the features also low latency, high reliability, and precise positioning, where we can use the feature sensing and high connection density. If you're going to the next use case, that is a use case of massive communication in the transport and logistic, where you can use it, and also in the transport, logistic, health, energy, environmental monitoring, and very important is, for example, agriculture, in order to increase the capacity of the food generation. So, and features are high connectivity, density, different data rate, low power consumption, this is important, mobility, and extended coverage. So, and then we come into the integrated sensing and communication. That is a very nice feature. So we have a network of sensors. Each mobile is a sensors. We will have a lot of IoTs, and these will give information based on the electromagnetic wave propagation, and that we can use also for AI in order to increase the capacity of the mobile communication systems. So, and then AI and communication, they will assist, for example, automotive driving, then autonomous collaboration between devices for medical assistance, and IMT 2030 assists collaborative robotic. But here have to look that we should not bring the private data into the global network. So this means we have to develop the model, and then we have to bring all the models together and to make to combine a new model, and then we can have a center of a general model. But this means we have to update it every time. And the point is where you want to have these centers. If you need only one center, or you need a center in each city, and that will produce a lot of cloud and also will produce a lot of optical fiber, which you have to use. And this means you have to look how you can make the AI very efficient in order to reduce the cloud. And if you're looking who are the market leaders for cloud, this means we have to look that we have here also a European cloud provider which can deliver all these things in order to make AI happen. So for the AI, we need here, yes, high area for support of high area traffic capacity, low latency, and high reliability. And here's important, if you use AI, we have to look what is the additional requirement for the latency. So and then the unique with communication, so it means connect all the unconnected people. So maybe that is also a slogan from Orange. They are very active in the African area, how we can use, for example, the satellites, the non-terrestrial satellite, in order to connect all the people around the world. So now, one success is we have a high network capacity demand, and we have to look that we can go between 6 and 15 gigahertz in order to fulfill the demand of the capacity. And we should look that we get a harmonized worldwide spectrum in this area between 6 and 15 gigahertz, maybe, and then also for the terahertz for sending communication. And then we should look how we can have a spectrum sharing between 5G and 6G in the lower frequency, in the FR1 and also in the FR2 for the millimeter wave. So summary, 6G go beyond enhanced communication. That will be not only a communication system, that will be more a communication, computing and storage system. So this means with the new two services, we bring in new features. Then we should have a smooth integration of 5G. So this means we have to do it very slowly and to make, for example, spectrum sharing between 5G and 6G, native support of I already discussed, and the balance of simplicity, performance reduce TCO that also we discussed. And we also support a unified and global standard because we need the global standard. If we have no global standard, then we cannot deliver the mass market with low prices. So then the 6G research has a global momentum. It's ongoing. So we have a lot of research activity in the United States, in Asia, and also in Europe. So thank you very much for your attention.
So now it's time for questions. So Egon, please stay here. And Peter will also join, and we have Elizabeth online. So audience will pose you some hopefully tough questions, and let's take them one by one. Wait for session assistant to hand you the microphone. Who wants to ask the first question? We have one right there.
Thanks. Joseph Noel, University of Oslo. Again, I'd like to get your opinion on what I see as a mismatch between your outer ring on sustainability, connect the unconnected, and all those questions, and the inner ring, which is what I call the technology development. Because for me, there is a mix or a gap in between.
So who wants to take this?
I think the question was more to Egon than
yeah, but everyone who develops
yeah.
You have an answer.
I don't think there is a disconnect, right? I mean, our technology development is geared to, especially with the focus on 6G, to the energy efficiency. Our technology developments are geared to also connecting the unconnected. So NTN we see as an integral part of that future architecture, and it's something that already happens in 5G Advanced. And talking about the unconnected, while I have the airtime, it's not only about developing worlds and rural areas with NTN, but also having affordable technologies for the urban poor areas, for instance. And also that, again, to your question, is part of the technology research that we are doing.
So Noel, are you satisfied with this answer?
Okay.
Maybe 5G was looking towards verticals needs more than global coverage issues to start with. So maybe there is one mismatch, maybe. Do we have another question? Okay. Colin.
Thank you, sir. Colin Wilcock, Chairman of the 6GIA, Vice Chair of the SNSJU. How can we justify 6G, especially in terms of business case and deployment?
Yep. I don't always need to be the first, but I'll take this one first again. And then we should also allow Elizabeth online, right, to take that question. But first off, yes, the first justification is the need for more bandwidth. That more bandwidth that I advocated already, factor of 10 at least, more capacity, you need to install new radio systems. And you need to install new radio systems that are significantly more power efficient. I think there already you have a justification. Second, there is a growing digital economy with AI and with cloud. And as I already advocated, the network is an essential pillar, and we should learn from the cloud and AI industry how they are able to make money out of that. And we should create an architecture that also allows us to tap into that value chain more. There's a lot of money out there. We need an architecture that creates the value, but that also allows us to tap into that value thanks to the API approach.
Okay. Then I can give also some remarks. I have made research for 2G and development and also standardization and for 3G. And then we developed 4G. And then I had a discussion with some operators. He asked me why we need 1G, 1 gigabit. They said we don't need it. So the justification is we have to push innovation in order to make more business and to connect the people. And now we have this 5G, we can connect everything. We have the message that we can connect everything. And now I said the world is dynamic. We have to push innovation and not to stand still and say that is. And then other people will bypass us and make new systems. So that we have the certification that we have to bring new services to our customer, to the clients, in order that they can develop maybe I want to say the justification that they can use it. If it's there, then they will use it. If it's not there, then they will not use it. So,
Elizabeth, do you want to make a comment as well?
Questions and the answers, but I picked up some snippets, and I think that the question was the why question, and there's really a lot of considerations. So we can just add very quickly from my side. So I think that it's clear that there are quite a few societal challenges that we would seek the response to via the new technology 6G, such as ubiquitous coverage to take one. I think secondly, the European economy, the European connectivity sector really needs new business opportunities. And then thirdly, 6G will be developed elsewhere if Europe is not around the table. So I think that from simply a sovereignty perspective, we will just lag behind and will be technology takers if we are not actually pushing ahead as we are today. Just to complement some of the other considerations that have been mentioned already. And sorry if I missed the topic. I can't hear properly what you're discussing in the room. Thank you.
Okay, we have next question coming from Tatu.
Yeah, Tatu Koljonen, Aalto University. I picked this beyond communication feature of 6G. So we had an industrial internet campus at Aalto, and their industry companies, they still view these 5G and 6G as a pipeline, wireless pipeline. And how do we change this? How do we, should we make 6G place where we can exchange digital twins between companies? That's what they want, to have models, a network of digital twins, and that would be easily accessible and could be utilized in generating tactics and strategies. So would that be something that the metaverse and this beyond communication vision would be about? And do we have a relevant research directed to that? And a bonus question: where does the quantum computer reside? Is it in? It will be ready when the standard 6G is running. Where does it reside? Is it in the network or is it in the cloud or somewhere?
Lots of questions.
Yeah, I said I wouldn't go first, but the question begs, because I did use the word digital twin and how digital physical fusion is the new application for Industry 5.0. And yes, it's more than just connecting. Of course, massive scale connecting of sensors is an important part of it, because it keeps your digital twin up to date with the most accurate information, sensor fusion. There is then the additional sensing capability of the network itself, the wireless sensing that I mentioned, but there's also a lot of data in the network that actually gives a lot of intelligence of what is happening in the network. So there's a lot of value in that data that we can expose through the APIs for such things as industrial automation, optimization of processes, for a societal benefit, for instance, also avoiding food waste. On the flight here, I read in the New York Times, there's a lot of food waste causing 8% of the global CO2 output, more than airline and shipping combined. And actually through installing sensors in restaurants at the dustbins, they can, for instance, figure out how much waste is going out there, and giving an optimization of portions of food, or also end of life, end of shelf time food in department store. Long story to give an example of how through sensors and networks and combining that with AI, you can actually create value and also have a societal benefit and create a business around it at the same time. So I think that is where the 6G network again can play an important role.
But how about avoiding this pit pipe development tradition? How to make 6G more than yet another efficient pit pipe? And I guess that's what's about it. So should we have a totally different type of approach, like this metaverse approach, where the application sharing, the application intelligence between different players and operators, would that make 6G more appealing? I guess that's what this.
And there's how to run the digital twins.
So maybe,
Well, Egon,
maybe that's a good idea. Maybe you have the data available, then you can make a business model, you can make a startup, and then you can deliver maybe digital twin for some verticals, maybe. So this means that is a good example what Elisabeth said, to make a European economy. That's maybe you have all the data available, you can deliver this and say, oh, I deliver your vertical twin maybe for e-health, for every vertical industry. That's a good opportunity.
Yeah. I think it's in the architecture, so making the APIs open, enabling that Internet of Value with smart contracts so that you can have these distributed business models, and then also work in the monetization of that. Do we want to go to the quantum question as well, or?
Why not?
Yes, maybe 6G will not deliver everything for you, but you have to look which APIs you want to use, and then can you go ahead?
So will quantum be part of 6G network integrally?
So quantum computing, whether it will be there on day one, maybe not, but it will happen in the 6G era. And quantum, we talk about quantum 2.0 because it's a whole set of things. It's not only quantum computing, it is also quantum communication, it is quantum sensing, it is quantum safe encryption. And the quantum safe encryption, for instance, everybody already understands that very well. You can hack code that's deemed safe today with a quantum computer in a couple of hours. So you need quantum safe encryption that needs to be there. Then the quantum computing will be another compute capability in the cloud. So for me, that is not so much something specific that we need to consider, except for when we go into, but that is further out, I would say, quantum networking, where we have distributed quantum computing to make those quantum computers scalable. And then you need indeed mechanisms to translate qubit states into photon qubit state and the entanglement. But that for me is further out. That's definitely not a 6G day one capability.
Okay, we still have time for another question. Aki wants to ask something.
And over there, Monisha as well.
Can I ask something before
Okay.
that? So, Sami Pesonen
Go ahead.
from VTT. So I would like to ask that how we make sure that rural areas are also getting proper network in the future. So for example, in the Finland, there's still a lot of areas that they don't still have a 2G network, and there are a lot of hunters and fishermen and reindeer herds that are lacking proper connections.
Okay, rural areas, global connectivity. How do we get it?
So rural areas, when it is hard to do with terrestrial solutions, then yes, satellites are the correct answer. We should, however, also keep in mind that there are radio technologies that have fairly large coverage. So the technologies are there, we're further developing them, and then complementing that with satellite technologies that is becoming cheaper. Satellite technologies that then also help us with ship corridors, air corridors, and such. But we should, in the digital divide, not only think of rural areas. Let me make that point again. It is also about bridging digital divide in affordable ways in urban poor. There are kids that are in Upper Manhattan that are camping outside Dunkin' Donuts because they don't have proper Wi-Fi access, so they get the Wi-Fi access to doing their homework. So doing it affordable also in urban poor is equally important.
Yes, because maybe we have started now with the NTN, that is now the time, and I think we will see a lot of progress in the next 10 to 20 years, how we can bring high data rate to the rural areas. So we have started, and then we will see what is the request from the people which are living in rural area and what they want to pay.
Okay, we can quickly take at least one more question. Sudhir has a microphone. Hard to stop him now.
Thanks a lot for very good presentations. I have a few comments and then questions. So it may be a long Q&A. So what I feel is that with a lot of innovation that we are all talking about, the technology is moving too fast with too many moving parts, and hardly there is time to stabilize. We may not know what we are doing. So if we look even from a technology perspective, when I hear these presentations, and I'm also guilty of the same thing, if you peel down in detail, very few people really understand what it really means from a product perspective, from a business perspective, except research, publication, IP, which is great. So that's one comment. And the other thing is, I think people ought to think about how to simplify things. If you keep throwing complexity, your system will never get stabilized. And we will always be in a transient mode in our world, whether we would not know. And that is true even with 5G. And this was the same thing with 4G, that it never delivered the performance that it promised. It is not doing that in 5G. And we are racing ahead for 6G. It is not to criticize, but that's our job as a researcher. So we need to think from a simplification point of view and allow some time to stabilize. Second comment is in the audience.
Maybe the question, we are running out of time.
Question, I'm coming to the question.
Yeah, 1 minute.
The second thing is, the technology is moving too fast, but if you talk to the product people, because I have been on both sides, their progress is always very slow. It takes a lot of time to develop a product, to roll it out in the market, to make the money, and so on and so forth. So there is a chasm here, there is a gap between these two communities, and we hardly see them being present in
Do you have the question?
And finally, the question I have is, Peter, you referred to architecture. If we don't have a an agreed architecture,
Yeah.
especially for 6G that we are talking about, it is very hard to put all these dots in place.
Yep.
So my question to you and to you would be, is there an architecture that has been agreed? And what is the progress towards that? Because unless we have that, we'll have too many moving parts and the progress may be slow.
Yeah, very good points, by the way, and I fully agree that, and it is actually a good way of reiterating my last slide. Indeed, we need to get the research and the system product development together and the standardization together. And that's why at Nokia, we work hand in glove already today with the business groups. And work on the long lead items like the ASICs, and we work hand in glove with our standardization people already today. And we had a sit together, a war room, to define, okay, what do we need to prioritize for day one? And that's what I summarized on the last slide. And you made the point, the architecture is essential there. And we have a view on what that architecture needs to be, and it needs to be simple, to your word. It needs to be simple. So not 7 options, 1 option, please. And furthermore, we need to have a framework in place. Yes, the development is moving slower than what research sometimes imagined, but the reverse is also true. AI has been such a fast-moving field that you need to be ready for such scenarios where you at least have the framework in place. So that is also a day one capability that we absolutely need to drive in the architecture.
Well, I can only say from my experience is that after 2 or 3 years research, and we working with the development department together in order to see what is possible, which features we can do, and that will go to the standardization. Yes, but for the architecture, for the time being, I have no idea how it looks like the architecture, because we have a lot of things in the cloud and we have to define the interfaces. So I'm not a network architecture guy, but I think that will become very hard, because how looks like AI? That is a module. Will we have an AI specific? Will we have a European AI? Will we have an Asia AI? Will we have a US AI? So I don't know. That is also a function, and how you can exchange this. For an operator is in the United States or in South America. I don't know. That is a hard topic, and AI is not easy.
Of course, we don't even know the exact ITUR requirements for IMT 2030. They haven't been yet stated. We have to wait for that first, and then right after that, maybe architecture. So I think this concludes our morning session. Thank you to all speakers, Peter and Egan, and Elizabeth online. Thank you.
Thank you.